Okay guys, I'm going to go over how to do these calculations in the Thermo Lab. So, alright, as far as the calibration of the calorimeter and you're trying to find the constant, you're going to use only step 1. So Q hot is for your hot water, Q cold is for your cold water, and Q calorimeter is for the calorimeter. So the heat that's given off by the hot water is the heat that is absorbed by your cold water and the calorimeter. And remember, Q is equal to MC delta T. So Q, which is the heat given off, is equal to M, which is the mass, times C, which is your specific heat capacity. This is a constant, times delta T. Sorry, I can't write very well with this mouse. Remember, delta T is final temperature minus initial temperature. So you could have a negative number here, depending on if your final is colder than your initial. So your Q for your hot is only for your hot water. So that is the mass of your hot water times the specific heat of your water, which is 4.184 joules per gram degree C, times the change in temperature of only your hot water. So your final temperature on all of these is going to be the same. The final temperature for your hot water is going to be the same as your final temperature for your cold water, which is going to be the same as your final temperature for your calorimeter. It's your initial temperatures that are going to be different. So the initial temperature for your hot water, you should have measured. The initial temperature for your cold water and the initial temperature for your calorimeter are the same. Okay, so your delta T for your cold and your calorimeter will be the same. After you find that, your constant for your calorimeter, the only thing that you don't know is the constant for your calorimeter, which you're going to measure for part 1. You can either calculate C or you can calculate MC. It doesn't matter because your mass isn't going to change and for your calorimeter, and your C isn't going to change for the calorimeter. This is the part that you will be using in part 2. So let's talk about part 2 now. So in part 2, you measured the change in heat for your salt when you added it to the water. And for part 2, you're going to use numbers 2 and 3. So here you're trying to find the enthalpy of solution. Just so you know, the enthalpy of solution is not Q of solution here. Your enthalpy of solution is the heat that's given off when a salt dissolves in water. And in this case, that's what the Q dissolution is. So the Q dissolution is the heat that's given off when your salt dissolves in water. That's what you're trying to find right here. And it's going to be in joules, and you will have to eventually convert it to kilojoules. And then I'll tell you in just a minute how to do kilojoules per gram and kilojoules per mole if you don't understand that. So basically, you know this right here. And you're going to have to calculate it. Your Q of solution is MCAT, or MC delta T. Now remember, right here of your solution, the mass of your solution is your salt and your water. Okay, so let's go back a minute. When your salt dissolves in water, that's Q of dissolution. All of the heat that's given off is going to be absorbed by your calorimeter and the water that you have in your calorimeter. But when it's dissolving, it is not only just your water, but it is also your salt. So be careful with this one because your mass here is going to be the mass of your salt plus the mass of your water. For the specific heat capacity, even though it's the salt and the water, you're going to use the specific heat capacity of water. It's close enough. Your change in temperature here is going to be the same for your solution and the same for your calorimeter. It's just final minus initial. The key here, though, for your calorimeter, your C, this is the C that you're going to use that you determined in your number 1 calculation. Okay, once you find out your Q of solution and your Q of your calorimeter. That's going to give you your Q of your dissolution. Once you have that, that's going to be in joules. Then you are going to convert it to kilojoules. Remember, there are 1,000 joules in 1 kilojoule. And then you're going to convert it to kilojoules per gram. This is in joules. You're going to convert it to kilojoules per gram. You should know how many grams of salt that you measured out. Okay? Don't put 5 unless you had 5.000 grams, or don't divide it by 5. By the way, this is an equation, so it's kilojoules divided by grams. So if you had 5 grams, 5.007 grams, you'll divide your Q of dissolution by 5.007 grams. After that, you also need to report it in kilojoules per mole. So convert your grams of salt to moles of salt. You're going to do a stoichiometry problem that way, or a dimensional analysis. You each had different salts, so don't forget to do that, because most of these are given in kilojoules per mole. After you have that, these are the 2 values that you are going to put into the spreadsheet. Spreadsheet looks like this right here. So if you were in second period, you're going to focus on this group right here. If you're in third period, you're going to focus on this group, and in your fifth period, you're going to focus on this group. So for second period, if you were in group 1 or 5, you go down to your salt and put it to there. I don't remember what group 1 had, but if it was NaCl, you would put your kilojoules per gram value that you calculated right here and your kilojoules per mole for salt right here, or NaCl. If you are in group 5, you're also going to use this column because you did not have the same salt as group 1. So in the end, automatically calculates the average for you for each of these. So in the end, hopefully by the end of Saturday today, everyone will have entered in their data. And then you can go in and look at all the averages. That's how you'll answer your questions in Canvas on your lab. By the way, these are the accepted values right here. So NaCl has 3.7 kilojoules per mole. It takes 3.7 kilojoules per mole to dissolve into a solution, to make a solution. So if you notice, some of these have positive numbers, some of these have negative numbers. Hopefully you can tell the difference between a positive and a negative as far as endothermic and exothermic. If you have questions, please ask.